Thank you, Barbette. I'll do my very best to live up to that introduction. I'd like to thank everyone for joining in today from wherever you are in the country or wherever you might be in the world. I'll remind everyone here that the National Groundwater Association has mission, vision, and goals that are spelled out that we adhere to very closely. And our NGWA mission is advancement of groundwater knowledge, and that is to wherever you are in the world. That's our utmost important task here, is to educate everyone to the best of our ability, whether they be a professional or whether they be a homeowner. Doesn't matter whether it's an engineer, a water well contractor, or where you're from. It's all the same. We need to continue the enhancement of all of our education. So I will, at this time, go right into the webinar. Today's webinar, the importance of water well system inspections to health and system operation. This is one in a series of online training modules by the National Groundwater Association with support from the U.S. Environmental Protection Agency. So the first thing I'd like to ask is a quick audience poll. Barbette will open up the poll. So if you could please make a selection that best fits your needs, whether you want to better protect your water supply, learn more about your water system, or learn more about general water system components or something else. That will maybe help me as we get closer to the end of the webinar, when the questions come in, be able to give you answers that are appropriate to what you're really looking for. So what can a routine water well system inspection do for you? A routine water well system inspection can help ensure the well system is operating properly. It can prolong the system's useful life, and we'll go into more of that as we get farther into the webinar. Barbette, I seem to have lost control of this thing.
I'm sorry. I see your presentation.
Maybe I got it back. I couldn't advance it. I think I've, for some reason, got it back here. To also discover water quality health risks due to system maintenance problems or contamination sources. So anytime that you open up the top of a well or get into an elaborate well inspection, it should be done by a licensed or certified water well system professional. And it should be done annually. There's some other tests that we'll get into too that would be recommended to be done annually. And each individual state, province, country would have guidelines based on their typical experience in their areas as frequency of testing, whether it be in the water quality testing or frequency of annual well inspections based on environmental factors or other things. Barbette, do we have any poll results at this time?
We do, and they're currently shown on the screen. 20% said I want to better protect my water supply. 10% said I want to learn more about my water system. 40% said I want to learn more about water system components, and 30% stated other. So feel free to type your other in the chat box so we can consider them. Thank you.
Thank you, Barbette.
You're welcome.
So a professional water well system inspection will include the following components. A visual inspection of the wellhead. So a visual inspection of the wellhead would look for the condition of the casing, any holes or pitting of the casing, any leaking around the casing, any depressions around it. Is the cap secure, and is it sealed properly? As you note in this photo right here, the conduit goes up into the end of the cap, and that's a threaded connection that needs to be sealed properly. That cap is also a bolt-together style design with a rubber gasket in there that compresses and seals against the casing, and it has a screen vent in it, a very fine mesh vent that that spiders and ants and those other kind of earwigs can't get into the top of the well. So the other thing would be, going back to the casing, is the casing at least 12 inches above grade. Need to keep that top of that casing up out of the grass and up out of where it may be influenced by surface water. So we go to a visual inspection of the well system, components, and other equipment. What's the condition of the pressure tank? Are there any areas on it that it looks like it's an old tank? Is there rust on a seam? Does it look like it's about ready to rupture? Because they are a pressure vessel, remember. They will run, most systems will run between 20 and 60 psi. Is the wiring neat and tidy? Is a pressure switch cover on? Are the wires properly run in conduit or properly affixed and covered? And then if you have a softener, you start to look at water treatment. We will cover that a little bit farther into this. Control box, is the control box cover, is a screw on it, and those kind of things. So then a physical inspection of well system components would be any other components, such as inline filters and connections, brackets, those kind of things. It's all the kind of stuff that over time we lose track of. As you can see on this page, there's a whole list of well system components and all the visuals. There are many components on there, as the item number 9 would be in a northern climate, would be a pitless adapter, which allows you to bring the water into the house far enough below grade, as you can see, to be below the frost line. And then in the little box up to the right hand side, you can see fixture number 12 would be a well seal, which would be more typical in the southern, where there were no freezing conditions. Many of those terminate at the top of the well, and I even see pressure tanks that are setting out right next to the wellhead, and then the water line comes into the building. Where I'm from here in northern Vermont, that'll last up until about 32 degrees and stay frozen all the way through until something in a matter of April or May. So we have to run these below grade in through the foundation wall and install the pressure tank and controls inside the building. In the southern climates, the pressure tank controls can be located on the outside of the building, either in a covered area or somewhere where they're at least protected from sun and rain. Many of the other pieces in the well components are, connectors, check valves, tank T, boiler drains. You have cable guards. Number 8 is a cable guard, which is used to keep the drop pipe standing away from the side of the well and protect the wires. And then on number 5 is a torque arrestor, which is something that stops the pump from putting a lot of torque on the line and spinning the wire and cutting the wires. And that will get you a premature failure of your pump, and then the need for a professional to come out and pull it and repair it. Those are things that are much harder to see. That would have to actually be pulled out of the well to be inspected. That would be a little bit more of an intrusive inspection. The well owners, as a homeowner, you can observe the area around the wellhead, and you can look for anything out of line around the top of the well, such as the casing condition, such as the well cap condition. And I've got another interesting slide in front here. These are things that a homeowner can look at and determine, ooh, it looks like there's a hole there. It looks like that pipe is broken. It looks like the cap is really crooked, and I never noticed that before. And those are the things you can look at, and because homeowners are the first line of defense. I mean, you're the ones that are on the site every day looking at these things, and there are some things that could be evident that could have water quality issues or longevity issues with your system. And as you can see, this is the work of a very hungry mouse. This is one that I actually pulled a couple months ago, that a mouse was, or maybe more, were living in the top of the well. They were chewing on the lines, and as you can see, the insulation was chewed away, and the lines went line to line with power, burnt themselves off, burnt up part of the nest, fried the mouse, and the mouse dropped down into the water supply. And I found the mouse carcass about halfway out as I was pulling the pump. And that was very simply a very poor conduit connection into the well cap, that mouse was able to live in there. There was a mouse nest, and the nest had actually continued, as the mouse lived in there, had continued to drop into the water and clogged up the intake screen on the pump. So they weren't even really getting a very good water flow into the house, and it actually sucked the screen in. So that's one really, really, really important place, and a homeowner can really watch their water supply and protect themselves, because that was a Sunday morning call, and I was there for about 4 hours by the time I dug through the nest to get to the pitless adapter and pull the pump. So something as small as that could save you hundreds of dollars and maybe thousands of dollars in well repair. And it's really nasty. You've got a mouse living in the top of your well, and there are other things that mice do other than bring things in for them to eat. So you think about these things. And here's a typical top of a well in a southern climate that could be terminated right above grade. That's a well seal and the pipe coming out. You can see there's a conduit there with the wires, and there's a hole there over in the closer part of that photo that probably a well screen should be in. There should be something there. They make they call it a gooseneck vent that comes up with a well screen in it. So that hole, all of these holes need to be plugged. You also have to be aware of other contaminant sources, whether that be household cleaners, whether that be a can of gasoline sitting out near the well, whether up here might be snowmobiles parked out near where the well is that could have a leak, fuel leak, gas leak, vehicle parking, all those kind of things. And there's a photo of Cooper. That was shortly after Deflategate, so he was a little jealous of Tom Brady at that particular moment in time. So he decided he was going to be a copycat. But even though they're adorable and mischievous, don't forget the impact of K9P to your well casing. Keep your pets away. Don't put a chain around the top of the well and let your pet live around your water supply out there. I have seen casings be deteriorated from pet urine, actual holes in the pipe where the acid ate through the casing. Farm animals, manure storage, farmyards, and collisions. That is, as you can see, the cap is askew on that piece of casing, and you got a gate there. Could be a tractor coming in and out. Just really want to start thinking about protecting these things. Ponding water, that water all setting around there, it's going down into the ground there somewhere close. If there happened to be a fracture or a poor confining area between the surface and where your water supply is, whatever happens right there is going to happen in your water supply. You see a small cement pad right there with a conduit connection that comes up out of the pad. These things are pretty typical, again, in a little bit warmer climates. A non-secure well cap. The non-secure well cap. This is where this is not a sealed cap. It doesn't have a good conduit going up into the front of it for the electrical wires to come in. And it doesn't have a vent, and it's not very well sealed. These are it was years ago when we used to have to set over wells, when we had a terrible earwig infestation here in Vermont, that we had to set over it with a drilling rig and clean these wells out. There were so many earwigs and so many bugs in these wells. These are things that a homeowner can identify and call a water well system professional, and they can remedy very quickly. Again, another photo of a non-secure cap. So well owners should observe the condition of above ground well system components and other equipment. A well professional should check anything deteriorated or broken for potential mechanical failure or health risks. pumping equipment. You can see the pumping equipment here. This is an above ground jet pump, single line jet pump from a shallow supply, whether it be a shallow drilled well or dug well. Wiring, controls, gauges. You can look at the pressure switch, see the cover on that pressure switch is on nice and tight to prevent anybody from getting into it, because there is most of the time either 110 volt or 220 volts there, so kind of protect your family by keeping the covers all on those and making sure that wires are run nice and neatly and connections are made correctly. Above ground storage tanks in some parts of the country, they utilize above ground storage tanks. Have to be a little more concerned about atmospheric storage, which is non-pressurized storage with vented to the atmosphere, because water stays in those for periods of time because there's a pretty large volume in there. You can get bacterial growth in there. You can also, if you don't maintain the openings, if you don't maintain the screens in them, in any of the connections where wires may go in and out, you may have a submersible pump in that tank, or you may have a centrifugal pump like the one in the first slide right here. You're going to make sure all the holes are sealed really well. They're probably going to have to be periodically disinfected because bacteria will grow in atmospheric storage tanks. Electrical control boxes. These seem to be outdoors. This is the left-hand box is a photo of a Grundfos SQE controller, constant pressure unit. And then the breaker over to the right-hand side of it. These things will function in hot and cold weather at a very wide range, but they don't like water. So you have to make sure that these boxes are well protected and sealed from the elements. Filtration. Water softeners. Make sure that the clocks are set. Make sure that that there's salt or potassium in the brine tanks, and this also has some sort of a chlorinator, either chlorinator or peroxide injection or something else due to water to offset water quality issues. Could be even something to balance the pH, lower it, vinegar, whatever it might be. So you got to make sure you maintain those tanks and make sure that these clocks on the top of the unit, you look at the very top of the unit, make sure the clocks show the right time of day so that it's not backwashing when you want to be using it and you're getting raw water into your house. Inline filters. While that inline filter might look a little bad, it could be just a little bit iron, it may not be plugged. Many inline filters will get a color very, very early in their life, and then they may last a long time before you start to notice a water flow issue. And that's how you can tell really when the filter needs to be changed. You turn on a faucet and you don't get as much water out of it. If you're using multiple faucets, somebody may not be getting any at all on the second floor of the house, and that's when the filter needs to be changed. So make sure you've got some spare filters and are prepared to be able to change that so that you don't let unfiltered water into the house. So here is a photo that I took just a few weeks ago. I went on a service call. Here is a perfect example of improper material use. This is a white metal pitless adapter that was in steel casing. And as you can see, there's a rubber O-ring on it on the lower right-hand side. That's where it used to stick through the casing. Because of corrosion, electrolysis, that fitting actually deteriorated to the point where it blew off inside the well, the pump slid to the bottom of the well, and the top of that pitless adapter was down 72 feet. So we created a tool to go down and fish it out of there, and as you can see, it's just a spiral tool. We went down, we fished it right out first time. So that was a really good day of fishing. Perfect example of dissimilar metals and the resulting corrosion related to failure. I don't know that a water well inspection, unless you pulled the pump, would identify that fitting, but if at some point in time before it failed, that it was probably 20 some odd years old, at some point in time, if somebody would have picked that out of there, they would have identified that that was a very poor pitless adapter and changed it before they had the potential for losing the actual system. So between annual inspections, call a water systems professional to evaluate if any of the following conditions occur. Anytime the top of the well is opened or you see some reason that something could get into the top of the well. If there are new taste or odor problems, if you smell a little something sulfurish, see any odd taste to the water, there's a change that's happened there. That's when you start to look around and say, okay, where is that change coming from? Is it coming from something that I can identify as a homeowner, or is it enough to where I need to call a professional to come out and really take a good look at it? If the water becomes cloudy water, could be surface water, could be any number of things, turbidity, could be contamination. So you have to pay pretty good attention to that stuff, and anytime that any of that changes, then you want to be considering calling a professional to evaluate it. If the well's not producing as much water, low flows, if you're getting sporadic water pressure, you may turn on the faucet, you don't get any, you might wait 5 or 10 seconds and you might get some water and then you don't get any more. It takes a long time for the pressure tank to fill up and for the switch points to open, the contacts to open. You could have an overloading condition, you could have a bad wire, you could have a bad motor. There's so many things that could happen there. But anytime you see that kind of stuff is a warning that something is about to stop working. If you notice a surging in the water, especially during showers and etc., that could be a faulty pressure switch. It could be a bad capacitor if it's a 3-wire system. Or if it's a permanent split capacitor in a 2-wire motor, it could be a bad motor. It could be something as simple as the precharge is low in your pressure tank if you have a bladder style air over water tank, and the air precharge is more than 10 or 15 psi below the working pressure of the system. You see some surging, and when you see that surging, then that means that your pump is probably kicking on and off in what we call hydraulicking. What that does is that every time a submersible pump comes on, it takes a lot of energy to get that motor from stopped to 3,450 RPM, which is the RPM that these motors run at, and that is heat. That heat has to be dissipated. If it starts and stops too much, the motor gets hot. When the motors get hot, the windings get burnt out, or it prematurely wears the wires out, or it prematurely wears out the pressure switch. So any of these conditions would be an identifier. Or if the water tests positive for bacteria, coliform bacteria, anaerobic bacteria, anything. Could be an algae, could be any of those conditions. But all of these conditions are indicators that, hey, there might be something going on here and I may want to call somebody. And most generally you call a contractor or water system professional. But on the phone we can talk about what the next steps are going to be. It may not always be a visit. It may not always be a service call to give your system an inspection. But if you have an annual inspection, if that person's paying attention, they're going to pick up on a lot of this stuff, and they're going to save you potentially that holiday Christmas call where, oh my gosh, I've got 15 people here and I don't have any water in the house, and this is an emergency. And then your water system professional comes out and repairs it. But holidays and weekends and those kind of things most generally cost more money and they're a much greater inconvenience. So there's a lot to be said for keeping an eye on your system. And you have to look out for any other contaminants that are a health risk. The annual water tests for coliform are a great indicator. And as you get to the other contaminants, nitrates, E. coli, etc., are also indicators of an issue that you have in your water supply. And none of those are really any good for you. So as we begin to get to the end here, you can visit www.wellowner.org to find out more about useful well owner tools, including we have a private well owner hotline. private well owner tip sheets, and more information on online well owner lessons, free well owner webinars, and more upcoming well owner webinars. And also don't forget to check wellowner.org for other online lessons if you have any questions. What should I test my water for? And that what should I test my water for also, if you have a local Department of Health, they would have an idea of regional constituents of concern, whether it be arsenic, whether it be radioactive isotopes, could be radium, could be uranium. There's so many things around different parts of the country that if you visit your local Department of Health, they will give you some real good guidance on what you should be testing for and help you with the frequency of that testing. I know in Vermont every year we should be testing for coliform and E. coli, every 5 years for arsenic and nitrates, and also radium, uranium. So there's several tests that our local or our state health department recommends yearly because they see the data. They know what we have. Also has information on how to maintain your well, how to keep your water safe, what to do if my well floods. We actually have a BSP, Best Suggested Practices, on how to remediate a well after a flood event, how to clean it up and get the bacteria, get the sediment out of it. How do I get water treatment? There's guidelines for water treatment, and what you should know about getting a new well, including what to look for in a contractor. Is that contractor certified, etc. What's a reputation? So some really good background stuff there. So whether it's a day on the water or drinking a glass of water, we must protect and respect our most precious natural resource. We have to pay attention to our water, our surface water, and our groundwater. The surface water ultimately ends up to be our groundwater. And this is a picture right on Lake Champlain, right in northern Vermont, right off the ferry docks in Burlington. It's one of the fantastic sunsets that we have there. So I guess at this time, Barbette, we will ask people to ask their questions and type them in and send them in, and you can read them to me, I guess.
Okay. Well, we do have a couple questions already. Let's see. I am a MWS and also a member of MWON. Always interested in learning more. Appreciate the session and more to come. Gooseneck on well caps. I recently saw one of those on a well in PA that dates back before World War II. Are gooseneck caps still used today? This is the first I have ever seen.
A gooseneck cap, or if it's a gooseneck vent, yeah. Gooseneck vents are still threaded right into the top of a well seal, and they have a screen right in the end of them. Now, it's quite possible that back then it didn't have a screen in the end. It could have just been an open pipe, but we actually, anytime we have a well seal situation that is up high enough, then we actually still use gooseneck vents in a well cap.
Okay. Let's see. Get another question. I'm not sure I'm the best judge of whether a part of my well system is deteriorated. Can you give me some examples of the difference between weathering or aging as opposed to deterioration? Any guidelines you can offer when I'm in doubt?
Well, if you have, like the outside, if you have a steel casing out in the yard and you get big hunks of metal coming off them, it's big scaling, that kind of stuff. There was a period of time back in the 70s and 80s where steel that we're getting to case these wells out with wasn't of the highest quality, but we didn't have any alternatives. We bought the best we could. If your pressure tank and stuff on the inside of the house down in the basement has got a bunch of paint missing, you see a bunch of bubbling on it. You know, any of those things are indicators. If it's doing it on the outside, it may be doing it on the inside. You know, kind of look for the depth of that. If you're just getting a little bit of pitting, most casings will be a little rusty on the outside. And PVC casings in the southern part of the country, many parts of the country, I keep referring to steel casing, but there's many parts of the country that use PVC or plastic casing, and you know, UV rays ultimately break that stuff down too. So, you know, if you take and walk around it, if it's got a little corrosion, if it's a little rusty, I wouldn't worry too much about it. But if you see big pits or you see discoloration in either paints or in your plastic casing or in your well caps, that kind of stuff, you know, those are the things to be looking for.
Okay. In terms of deterioration, what is the most common problem you see with household wells?
Probably the steel casing, the casing that goes down through the overburden, and over time, you know, PVC will become brittle. Steel casing will ultimately corrode to a point where it's not structural enough to hold out the overburden. I've had them where they're threaded together or welded together, that they've eaten through there in those joints, and we've had to go in and reseal them. So, you know, that again, that goes to your water quality piece. I've had a few here lately too where groundwater was able to pool around the well, and premature failure of the casing with big holes in it. Like, you go back in some of the very first slides where the holes are in the casing right there, just pooling groundwater around there, and the low pH of rain, acid rain they call it, the pH of the rain is low, so that's trying to absorb other nutrients or other constituents into the water, and it's eating the casing right at the grass level. You know, that seems to be in the surface of the casings, and those things is what we're seeing to be the biggest factor.
All right. I haven't seen many wells with a concrete pad around the wellhead. Is that really necessary?
I don't know that it's necessary. In northern climates, I'm not sure you would even want it on the surface, because if the frost got in underneath it, it might actually pick the casing out of the ground if it was adhered to it too much. In southern climates, I would think it'd be pretty nice, keep it nice and clean around the well, and especially if you add a little dome to it to shed the water. I've drilled in third world countries, and in a third world country there's a big cement pad that's put around the well to protect it from dirt and you know, animals getting close to it and those kind of things. So I don't know that it's necessary. I think a really good slope to the grade around the well and a material there that will shed water and keep it away from the top of the well. So that necessary, I don't believe it, but you know, certainly not impractical in warmer climates.
Okay. When you say non-secure well cap, do you mean loose or something else?
I mean a well cap that doesn't have a some sort of a gasket, whether it be a rubber O-ring or a rubber gasket on the inside, and a bolt down design so that when you tighten the bolts up, it compresses it against the casing and it fixes it there, so it is neither loose or has any air gaps so that ants or spiders or earwigs or mice or anything else can get into. So that is a non-secure cap in my book. You know, you can certainly take a cap that has openings large enough, such as I call them a candy dish cap, candy cap. The only thing they should be used for really is to hold candy on somebody's desk when they're upside down, because there's a gap around the outside of it there that's about 1/8 of an inch that anything can crawl into. You can tighten it down so it doesn't wiggle, but it's not an effective uh, it's not effective for preventing anything from getting into your water supply. So secure versus non-secure. Secure is gasketed and screen vented. Non-secure is non-gasketed and non-screen vented so that anything can get in.
Okay. How much does the average well inspection cost?
Depends on what the level is. If you want to do a visual inspection around the surface, let's say you go and have somebody check the air in the pressure tank and they check the pressure switch and they make sure all the wiring is good. And they may shoot the ohms reading of the motor. I know our level 1 inspections that we check the amperage draw of the motor. We shoot the ohms of resistance to the motor to see what the health of the motor is. We'll go out and check the well cap. We'll probably take the cap off, look at the wires in the top of the casing, make sure everything is secure out there, put it all back together. That's about an hour. Some parts of the country, it probably would range anywhere from $85 to $150 or $175, something like that, for like a 1 hour inspection. If there's much to repair, then it might run into something a little more than that. But that would be a standard inspection without pulling pumps and those kind of things, if they didn't think it was necessary. But so somewhere in there, anywhere, and our country has a very wide range of costs depending on travel time and pay rates for technicians and that stuff. So somewhere between 85 and 175.
Okay. I've heard about cameras that can be lowered into the well. Are those used for well inspections? What is the well company looking for?
Yes, we do inspections. We have a colored camera, slimline colored camera that we can run down in a well even with a pump in it. Most generally, you get into that is a pretty aggressive well inspection. Usually a camera is brought in when there's a problem that's been identified, whether it be water leaking in, a coliform issue that you can't get rid of, colored water, you might have some turbidity in the water you can't get rid of. You may have sediment in the water or something else going on down in there that you want to go and take a look and determine at what levels something may be entering the well, or whether there's a breach in the casing, issue at the interface between the end of the casing and the bedrock, those kind of things. So that's usually secondary to a regular annual inspection. That would be, okay, we've identified an issue and we need to know where this is coming into this well so that we can repair it. And that's when a camera would be utilized. I know they inspect well screens with cameras after cleaning, and that way you can verify that all the mineral incrustation has gone out of it, that you've had an effective cleaning your well screen, those kind of things. So it's usually the second step, the next level of investigation into a problem.
Should I remove my well cap and look inside the well? If so, what should I be looking for?
Well, if you take off your well cap, you have to be careful because there's power there. So I'm probably going to defer to let a well system professional take the cap off. If the cap looks good and secure and everything is functioning properly, if it's a submersible pump, there's going to be some wires there. There are going to be some connections there. They should be heat shrink splice connections, butt splice with shrink tube and silicone. You may see wire nuts where the wires are put together at the top of the well. If the wires are too tight around the top of the casing, the tape may not be holding, or cable ties, whatever would be affixing the wire to the drop pipe. The wire may be slipping down and creating a ball down near the pump, and that's a place for premature failure. But I would recommend that if you we're thinking about taking the cover off the top of the well as an inspection type thing, that when your water system professional was there, you would let them do it. Because you drop something down in there, if something goes askew, then I've seen homeowners that open up the top of a well and wrenches end up down there, sockets end up down there, and then something gets wedged up against the pump, and then you get a lot bigger problem. So I would defer to a professional, either certified or licensed professional, when I started taking the cover off the well.
Okay. Now let's see. How often should I get my well inspected, or should I only get it inspected when I notice a change in the water?
Well, certainly a change in the water would invite an inspection, but we're recommending an annual inspection of the water system components. It's pretty cheap insurance. Somebody could identify an issue. Let's say your pressure tank was losing air, that your bladder was bad in the tank, and eventually all the air goes out of the top chamber of it, and the ensuing, let's say the pump's been in 10 years, and because it's been starting and stopping several times every time you open a faucet, it wore out the wires down the hole, and it burns up a motor. So then you have a water emergency. Chances are you're going to replace the pressure switch, you're going to replace the control box, you're going to replace the pump, and you're probably going to replace a bunch of that wire. We're talking about a couple $1,000 deal, where if every year you had somebody who spent that, $100, $150, $175, whatever it is, to get somebody to look at it, they may prevent that. The other thing is, it may prevent if you have a pressure tank that's bad. There's things that we as professionals can see very quickly that a homeowner might not notice. So my recommendation is to have somebody come out and take a look at it once a year, and sort of look around. It may save you an emergency situation and a lot of expense.
Okay. Thank you so much for that. We'll give them a few more seconds and see if there's any more questions. Is there anything you would like to add to the presentation today, Jeff?
Well, yeah, there's some really good questions there. And like I say, no matter where you are in the country, I think the emphasis on these are, what can a homeowner do to prevent premature failures and to protect their water supply? And hopefully we've identified many of those things today that you can look for, just kind of keep an eye on, and that the professional, the right professional will come out. They won't be very long, and they'll identify things that could save you issues down the road, and may ultimately protect your water system and your family's health and well-being. Also, there may be somebody next door that this water system professional has seen something in the groundwater or a condition that they may be able to help you down the road from having either a water quality or water quantity issue. So hopefully I've covered that so that you can identify those things. But it's just great to have this many people signed on to these, so that that many people that are interested in protecting their water supply and learning more about water systems.
I agree. Well, at this time we don't have any more questions. Jeff, we really appreciate you taking the time out your busy schedule to share with the audience today.
Well, absolutely, absolutely is my pleasure. It's been my great pleasure to be president of the National Groundwater Association and a certified contractor, and be able to assist people in their journey toward protecting their water supplies. So thank you to everyone for attending this webinar today. I appreciate it.
Oh, please do take a few moments to complete the brief evaluation that will open a new window shortly. Again, we appreciate you taking the time out your day to learn about the importance of water well system inspection to health and system operation. Thank you again. This concludes our presentation. Have a great day, everyone. Goodbye.